Okay, now we're back. We're going to look at the relationship between this method that we've been using to solve the quadratic, completing the square, and the vertex form of the equation of the quadratic. So notice right here we have x squared plus 6x minus 10 is equal to 0, and we have the vertex form of that equation, x plus 3 squared minus 19. Or I should say the vertex form of the quadratic, x squared plus 6x minus 10. The vertex form is x plus 3 squared minus 19. Notice that also gives us the location of the vertex, which is to say that we take whatever's in the parentheses here in this vertex form, so x plus 3 squared. The vertex is going to be equal to the negative of this number, so we have negative 3, and then it's going to be equal to whatever we've added or subtracted here. That's going to be the y value, negative 19. Okay, so let's quickly step through the completing the square process. So we first we added 10 to both sides, then we formed the x plus 3 square, then we filled in the missing pieces by adding 9 to both sides, so we end up with x plus 3 squared is equal to 19. So you notice the relationship here that we have x plus 3 squared is equal to 19, and here we have x plus 3 squared minus 19. Well, if we subtracted the 19 from both sides here on the completing the square, we would have x plus 3 squared minus 19 is equal to 0. So they're really doing the same thing. Let's take a look at what happens now as we change the value of the c, the negative 10 here. Notice what happens to our solutions. By the way, our solutions are negative 3 plus or minus the square root of 19. The solutions represent the x values of these two blue points here. Notice that the middle of these, which is the negative 3, is exactly along the same vertical line as the vertex. So we have negative 3 plus square root of 19 and negative 3 minus the square root of 19, giving us the 2 points where this intersects the x-axis, therefore giving us the solutions to our equation. Okay, notice now what happens as we change c. Okay, every time I increase c by 1, the vertex slides up by 1. Notice what happened here. When I got to the c of negative 7, I ended up with 2 integers for my solutions rather than numbers, something plus or minus the square root of 17. Notice again, this is where it's crossing the x-axis at 1, 0, negative 7, 0. Whenever we have integer solutions, it means that our quadratic can also be factored. And that's something that we'll come back to. In other words, x squared plus 6x minus 7 can be factored, and it can be factored to x minus 1 times x plus 7. Again, we'll come back to that. Okay, as we keep going now, the vertex keeps sliding up. Again, we have integer solutions here. X is 0 and 6. Now eventually we're going to hit it so that the vertex is going to be exactly on the y-axis or the x-axis. At that point, our 2 solutions are going to overlap and become just one solution of x is equal to negative 3, which of course is the x value of the vertex. Notice that when that happens, we have the equation in the form x squared plus 6x plus 9. This is a perfect square trinomial because this is exactly equal to x plus 3 squared. Whenever our vertex is on the x-axis, it means that our quadratic has to have the form of a perfect square trinomial. So for example, if we change b to 4 and c to 4, we again have a perfect square trinomial, x squared plus 4x plus 4, and it has just one solution here. X is equal to negative 2. Again, the reason for that is because the vertex is exactly on the x-axis. Notice now as we continue sliding c, we've now moved the vertex above the x-axis. Those blue points have disappeared. The reason is that our quadratic no longer intersects the x-axis. We have no solutions. No value of x will make this quadratic have a y value equal to 0. So, and we can see that reflected here in our solutions because we have x is equal to -2 plus or minus the square root of -1, but -1 does not exist. So whenever the vertex of an upward-facing parabola, like we have here, whenever that vertex is above the x-axis, we're not going to have any solutions to our equation because we're going to end up with an equation that has solutions with square roots of negative numbers, which, at least in the set of real numbers, do not exist.